I mean, ultimately it boils down to risk, right? So what you need to do is measure risk, and if you can measure risk, that means you can hedge positions for anything you have open, any open trades that you have. It also means that you can price new products effectively and bake that risk into the price that you give your customers. Right. But also regulators, both internal and external, need to have a good, need to have confidence that you have a good handle on the risk that you're taking. Just to back up a little bit, like the architecture, the way this has been done in financial services evolved quite a lot over the last 20 years or so, from Excel in the early days through to on-premises clusters to try and parallelize the workloads, through to on-premises grids that try to centralize that and have big multi-tenant architectures to really drive up utilization. But we've seen quite a big change at the moment as customers transition to cloud. You know, some of these clusters of thousands of servers, hundreds of thousands of vCPUs, are just not sustainable on premises. And so they're looking to cloud to, in the first cases, perhaps augment that capacity and have some capability to burst. But ultimately, customers are saying, well, we don't really want to run this stuff on-prem at all. So FRTB rollout is in progress, and you know, the rate of rollout depends on the jurisdiction involved. So different banks are at different stages of that process, but they're all planning for it. And again, it's another driver towards the use of cloud, because it just means that they have that extra flexibility.
And I guess if you're in one of those regulated domains where if your FRTB workload, that your batch that you run overnight doesn't run because, you know, I don't know, you had a power outage or something in your data center, you're going to have a hard time. You're not going to be allowed to open the doors for the bank in the morning potentially.
Yeah, you know, the risk of failures of an overnight batch can be mitigated a bit. So previously on premises, you know, if you had a failure of your batch in the middle of the night, you've only got, say, 4 hours to kind of catch up that time. One of the benefits of cloud is you can potentially compress that batch by scaling much higher and completing it much more quickly. So if you complete your batch by, say, 10 p.m. and find there's a problem, you've still got plenty of time to rerun and redo those calculations.
Instead of your overnight batch being an overnight batch, taking 8 hours, you could get it done in an hour at the end of the day.
Yeah.
You know, straight away after trading closes, you get your 1 hour, you get your batch done with 8 times as much hardware, but in 1 hour. And if anything fails, you've got 7 more hours to rerun it, or actually probably more than 7, but you know, you get the idea. And I mean, it's that elasticity thing coming back again, right?
Definitely, yeah. I mean, Spot is really transformative for some of these workloads, and we have customers using millions of vCPUs of Spot capacity to do just that.
Right.
I think the benefits of Spot are not only just that. It's just the reduced cost, of course, but the ability to flex up to those very high levels, but also combined with on-demand. So on-demand gives you that kind of confidence you have the capacity. So what we see is customers will provision the on-demand that they need to kind of meet their SLA, and all the Spot gets layered on top, and potentially best case scenario, they finish their batch really early, but they still have the confidence that they've reserved that on-demand capacity to meet their SLA.
Right. What about architecturally? What kind of services are people using to do all of this stuff?
Yeah, so
a lot of stuff.
Very much at a transitionary stage at the moment. So some customers have these kind of commercial grid schedulers that they've been used to using on-prem and want to move those over into the cloud. Yep. And that's, you know, from a lift and shift perspective, is a great way to go, and it kind of means that there's continuity as they do that migration. Yeah. But increasingly, what customers are realizing is that those commercial schedulers are very good at managing tasks. They're very good at scheduling and maximizing the use of a fixed set of resources. That's what they're designed for. Yeah. They can make very high velocity scheduling decisions. But as you move to cloud, where you have theoretically limitless capacity and all this kind of Spot capability that you could take advantage of, the pressure moves away from task scheduling towards effective infrastructure orchestration. So effectively, if you have workload outstanding, why not just bring in more capacity to get that workload done just as quickly as possible? Yeah. And so the focus shifts from task management to infrastructure orchestration. And so the tools that customers want to use and the building blocks that they use for these systems is starting to evolve. I think the other thing that's changed is that kind of multi-tenancy is going back towards single tenancy. So the on-premises clusters are designed to drive utilization through multi-tenancy and having very clear rules about how you prioritize those various tenants. As you move to cloud, because you can scale individual clusters very granularly and make sure you're always, you know, not over or under capacity for each individual customer, if you can have a lightweight enough scheduling environment, there's nothing stopping you having many separate clusters, because you can still be efficient by doing that.
So that means you could have a cluster for each trading desk.
Exactly, yeah, and we're starting to see that kind of federation of clusters happening with some of our customers.
Right. Okay. And what kind of services are they using?
Well, I'd say at the moment where they're lifting and shifting their existing scheduler, it's primarily EC2. But for customers who are exploring, some of these more cloud-native approaches and using some of the building blocks that we provide, even a simple queue like SQS can be tremendously powerful. It's multi-AZ, it's highly available, it's very high performance.
Extremely high performance,
and through a sort of greedy worker pattern, you can achieve some really high scale and high throughput with a very simple architecture.
Because in the very next episode in this playlist, we're going to dive into one of those solutions with one of the engineers from the team that's built it.
If you're enjoying these videos, please give us a like and consider subscribing to the channel so that we can keep making more to help you understand how the cloud works and to show you new ways to help all the scientists and engineers around you who use HPC every day to do amazing things. It's what gets us motivated as well. See you next time.